Okay everyone, so as part of your tests, about 50% of all your marks are going to come from problem solving. So what types of questions could you get? You could get averages or percentages, maybe increase or decrease in percent, ratios, graphs, line graphs or bar charts. You might need to extract information that you're provided with. You might need to analyze some data or interpret it in some way, and you might need to do some predicting. Averages, first of all, simply add the numbers up and divide by how many there are. So, an old question. None of these questions that you see taken from papers are actually going to be in the tests, by the way. So, add all these different numbers up, showing the fiber content in all of the vegetables, and the average fiber content is 196. Divide it by the 6 different values that you get, and that's a result of 32.7 grams as an average. Percentages. It's a number. A percentage is basically a number representing a fraction of 100. So for example, let's say you got 25 out of 40 for a test. That is 25 divided by 40 times that result by 100 gives you 62.5%. Now let's have a look at these graphs here. The first graph is representing a percentage decrease in value. So the value of number 1 on the x-axis is 30. It decreases to 25. Okay, now to work out that percentage decrease, it's reduced from 30 to 25, so it's reduced by a value of 5. So that is 5 out of 30 times 100 is a 16.7% decrease. Now on this graph, the second graph, this is showing a percentage increase. So the first value is 40 and it increases to 60. So what is the percentage increase from 40 to 60? So it's the percentage of the original value, 40, that you represent as a percent. So it's increased by 20 out of 40. So if it's increased by 20 divided by 40 times 100 is a 50% increase. Ratios next. In this question here, 12 grams of protein and 3 grams of fat per 100 grams. Calculate the protein to fat content. 12 to 3 can be simplified as 4 to 1. What you're looking for is the highest number that can go into all the numbers present in the ratio that you're given. So the highest number that can go into 12 and 3 is 3. And there are 4 3s in 12 and 1 3 in 3. So the simplest whole number ratio is 4 to 1. So have a go at this one. 85 to 45. So what is the highest number that can go into both of those numbers? So as far as I'm aware, it's 5, and that is a ratio, the simplest whole number ratio of 17 to 9, because there are 17 5s in 85 and there's 9 5s in 45. So when you're doing graphs, you're given data to do your graph with. Usually you will have to produce scales, accurate scales on your graphs. Make sure you have a 0 for the scales. You'll have to produce accurate labels for those scales, and the labels, what you use are the ones that you're given in the table of data that you're using to make your graph with. So labels with units as per what you see in the table, and then a correct plot, be it a line graph or a bar chart. If it's a line graph, make sure the data points are plotted accurately on the graph and they're joined together with a straight line using a ruler. If it's a bar chart, draw the bars clearly. If there is any shading, make sure it does not go outside those bars. So, an example, we have the hatching time for little baby trout and how long it takes them to hatch in days against different temperatures. So it says plot a line graph of the data on the grid below. You're already given the label for the x-axis, which is temperature. So your plot for the scale is like so for the temperature, 0 up to 20. If you are given a certain area of graph paper, it is ideal that you use most of that graph paper area that you provided, and this scale fits in very nicely across the entire piece of graph paper that you provided with. So that's the temperature scale done. You do another scale with another 0 for the time to hatching in days, and there's a little hint that they should have a 0 on each scale of the graph, because you're given two little points there at the beginning of the graph paper where each should be provided with the 0 at the beginning of the scale. So there's your scale, which fills up the entire graph paper there for the hatching in days, and make sure of course you label it properly as per what it says in the table of data, and the correct data plot is like so. Okay, so that's a line graph. Another example, bar chart. You're provided with data in the table at the top, and the time to digest has already been done for you in minutes, so the actual scale and the labeling has been completed for the x-axis. What you need to do is complete the bar chart with a scale on the y-axis, a label on the y-axis, and complete the plotting of the bars. So there's your scale. My numbers are on the side, by the way, because that's how it works best in the PowerPoint. And of course, as per the table, number of people, which is your label for that y-axis. Remember to put a 0 for the scale, and plotting the bars like so. Okay. Next, extracting information. You will be given a couple of paragraphs maybe to read, and you have to extract the answers for the questions that you're asked directly from that text. So have a little read, pause it and have a little read of that. The questions for it: how much tea is drunk daily in Britain? And the answer is about 135 million cups. What's the most common mood whilst drinking tea? Relaxation. Apart from cancer, what disease can tea help prevent? Heart disease. Name 3 types of cancer that tea may help prevent, which is lung, bowel and digestive system cancer. What 2 substances are not present in South African red tea? That's tannins and caffeine. And 3 styles of tea mentioned in the passage that people are now trying. And you've got 5 choices, any 3 of organic, chai spice, decaffeinated, herbal or iced. You may also be asked to analyze data or interpret results. And we are back to our little trout hatchlings again. Now, the graph's not present this time, but you can see from the data in the table what the relationship between temperature and time to hatching is. So, what is the effect of increasing the temperature on hatching time? And it is quite simply, as temperature increases, the hatching time decreases. You may also be asked how to predict what's going to happen next in maybe a series of data in a table or presented in a graph like so. So we have a simple graph of time on the x-axis, number on the y-axis, and we have a bit of a negative relationship going on there. As time is increasing, the number is decreasing. Now, if you are asked, for example, predict what the number would be if the time were allowed to increase to 13, all you would do is just follow that trend, follow that line of the graph, and of course it would give you an approximate value of a number of about 10 for a time of 13. Okay, thank you very much indeed. Goodbye.